All right, great. So welcome everyone to the ISS National Lab MISSE solicitation webinar. My name is Ryan Reeves. I'm a materials scientist here at the National Lab. Joining me on this webinar is Mark Chambera of Alpha Space and Mike Roberts of the National Lab. I will first open by giving a brief introduction to this solicitation and some of the important information regarding submission of your proposals. Then I will turn the presentation over to Mark, who will be going through the MISSE facility and Alpha Space's capabilities. Finally, we will open up the webinar to questions from the audience. Note that all participants are in listen-only mode, so we will be continuously accepting questions throughout the webinar, so please submit those in your questions sidebar. We'll be posting the question and answers on our solicitation website. The webinar will be recorded and will also be available on the solicitation webpage. If you have any technical difficulties during the webinar, please post your issue on the questions sidebar and Justin from IT will help you out. We are excited by the release of this solicitation on exposure of materials and devices to the extreme elements of space. So with that, let's go into some of the details of the solicitation. The purpose of the solicitation is to use the ISS National Lab for investigations of material science and device testing that require the external space exposure on the outside of the ISS using the MISSE flight facility. Full proposals will be due at 5 p.m. Eastern Daylight Time on May 22nd and should be submitted on our website. Please note that this is essentially a one-step solicitation and that we are not requiring concept summaries for this solicitation. We are only accepting full proposals and you do not require an invitation to submit a proposal. At this time, we expect that notification of award will be in June of this year. For questions about the timeline of the payload flight, you should discuss the details of your experiment with Alpha Space, and the timeline will be subject to MISSE schedule availability and the requirements of your experiment. So now a couple notes of important information. As part of the award, costs associated with the payload integration and services for Alpha Space are covered under this solicitation, as well as the costs associated with transportation to and from the space station, operations on the MISSE flight facility. Please note that we are not considering funding for project development costs. This includes materials and principal investigators costs to develop the materials and devices on the ground prior to delivery to Alpha Space. So when filling out your budget aspect of your proposal, the only funds that you will be able to request from the National Lab will be the implementation partner costs, those being of Alpha Space. As part of your proposal, you will need to deliver a statement of work and budget that will be supplied to you by Alpha Space. So prior to your proposal, you will need to talk with them to go over your project requirements. We encourage you to do this as early as possible so that you may learn of the capabilities of the hardware and work out all necessary requirements with Alpha Space ahead of time. Proposals will be evaluated on the basis of operational feasibility, scientific merit, and benefit to life on Earth. So specifically, we're looking for proposals that require the exposure of the extreme elements of space and have a direct benefit to life back here on Earth. One last requirement is that all offers must be US persons. So again, we're very excited about the release of this solicitation and the opportunity for new experiments. The deadline for full proposals is again May 22nd, and you can find more information about the solicitation and the guidelines using the link here. Please post your questions in the questions sidebar as we go through this. And with that, I'll turn it over to Mark Chambera of Alpha Space.
Thank you, Ryan. And hello, everyone. So I'm Mark Chambera. I'm Director of Business Development for Alpha Space Test and Research Alliance in Houston, Texas. And I'm really glad that everyone could join us today. And I would certainly like to thank everyone involved at the National Lab for pulling this webinar together. I know it takes a lot of work, and they've done a great job with it. So Alpha Space is really excited to be a part of, the MISSE RFP. And I have a few slides that will go over just the very basics of the MISSE facility, and then introduce the company briefly as well for everyone. So the MISSE facility really it's meant for rapidly advancing a technology. Certainly for those technologies that are meant for use in space, but also for terrestrial technologies that may want, extreme exposure to extreme environments in a very short amount of time. So what's needed if you want to rapidly advance your technology? So certainly you need consistent access to the test platform. And MISSE provides that. So we have 2 launches every year, every spring and fall. We're taking things up and bringing things down from the facility. And that's important. I mean, hardware return for evaluation is important for rapidly advancing something because you want to see how your technology performed, right? You want to inspect it. You want to see what failed, what went right. So we have 2 return flights per year. And the platform needs to be flexible. MISSE certainly is. We can accommodate on the platform virtually any size of experiment, within reason, of course. Any exposure face and direction in orbital direction, RAM, zenith, wake, nadir, and also any kind of passive experiment or an active one that requires powering data. So you also need something that's modular if you're going to be going up every 6 months and coming back down. And we certainly have a standardized way of integrating experiments, technologies, payloads into a modular carrier. And they're plug and play for the experiments, really. So, but, if you need to have them customized to fit, then we certainly can do that as well. Our team is highly experienced. We've got a long spaceflight history with the MISSE program. It went commercial in 2018 when Alpha Space took over the MISSE platform. But our team has been involved with MISSE since the very beginning. So since early 2000 with MISSE 1. And we just recently launched MISSE 13. So our team has experience with over 13 missions on MISSE. And from a reliability standpoint, more than 98% of the experiments that have flown on MISSE to date have successfully collected data. So a little bit about Alpha Space. So we own and operate the MISSE facility on ISS. We've got agreements with NASA and National Lab, of course. We are a National Lab implementation partner. We're also a commercialization partner, and we've negotiated all of the utilities, the services, and whatever is required to get experiments and technologies on orbit. So that's a seamless transition for any kind of customer that comes to us. You only deal with Alpha Space, basically. We're a small company, so we're minority woman-owned as well. And we have the AS9100 certification as well as the ISO 9001 certified. So we've flown 780 experiments to date, and that's since 2018 when it went commercial. That's only since the Alpha Space commercial part of it, MISSE. We've had 5 commercial missions, 9 through 13. MISSE 14 will launch in September. And on MISSE 14, we'll have 5 carriers. We call them MSCs, MISSE Science Carriers, that will be launched. And then we will bring back 5 carriers that have been up there for 6 to 12 months. MISSE 15 is planned in March, April, one of those months in 2021. And we are still accepting new experiments for the MISSE 15 flight. And that will have to be delivered, the hardware would have to be delivered to Alpha Space by about November of this year. So as I said, MISSE has a long history. So the first MISSE was in 2001, and it was a NASA sponsored payload. And it went NASA through the MISSE 8 mission. And then after that, starting with MISSE 9, Alpha Space got the rights to the MISSE platform and upgraded it, made it much more flexible, much more unique, I think, in the way that it exposes and it tests things in space. And it's been on orbit. We launched the facility in 2018. So really, we've been operating on orbit for 2 years now. And the flexibility in the platform is that you can get virtually any orbital directional exposure that you would want, and even simultaneous exposures by going on two faces of the facility at once. So the zenith face, which is pointing directly into space, directly opposite of the Earth, has unfiltered UV and gets solar noon occasionally. So that face is very popular with solar cells, the people who want to test solar cells. The RAM face is facing into the direction of travel of the ISS, and it gets a lot of atomic oxygen exposure on that face. So it's a very harsh environment from AO standpoint. The wake face is the exact opposite of RAM. So it's like looking out of the back of a moving boat, right? So it has an ultra-high vacuum microenvironment, and it gets very little AO exposure. So many times customers who will want a simple material exposure to see how it reacts to atomic oxygen will put a control on the wake phase to see, how much is really due to the atomic oxygen and how much might be due to other factors on orbit. The nadir phase has a partial Earth view. So actually the truss of the ISS is right below the MISSE facility. So if you're wanting to look at Earth, then you will be offset a little bit. So maybe about 30 degrees or so from directly down. All faces get the vacuum, ionizing radiation, the charged particle environment, all kinds of thermal cycles. Space flight gets a lot of every 90 minutes. So you have an orbit, so there's darkness and sun. And thermal cycles are pretty extreme. And also there were some micrometeoroid hits that we have experienced on the MISSE facility. So you can also fly an experiment that would be what we call contained in the carrier. So it wouldn't necessarily be directly exposed to atomic oxygen or UV, but it would be inside the carrier structure. That's a very popular place for electronic boards. We try to make this very easy for our customers. So customer contacts us to deliver the experiment to Alpha Space about 5 months prior to launch, and we do everything else. So we pack and integrate the experiment into our carriers. We do all of the NASA documentation and all of the reviews required. We do the flight certification, which is the NASA approval for flight. We arrange for launch. We launch currently on a Cygnus or a Dragon. And we typically do 6 months on orbit, but 12-month exposures are also available. We return in a SpaceX Dragon, and then the hardware gets back to the customer about a month after splashdown. So importantly, I think for some, especially a government customer, we do have government contracting vehicles available, so it's really easy for commercial, of course, and then also for government customers to come to use our turnkey service. Like I said, it really is fast. It's easy. You make contact with us. We'll complete some paperwork, probably a non-disclosure agreement when we start. Then we'll get a contract in place. We'll get an interface definition document in place with you for your experiment or technology. We'll do the integration, flight certification at the carrier level, so not at the experiment level. And then we'll get you onto a launch. And we have launches about every 6 months. So if you didn't quite get in time for getting one launch that's coming up, then you'll be in line for the next launch. We'll stay on orbit and do our on-orbit operations from our payload ops control center that's at Alpha Space in Houston. And then we'll get it returned to you. So we'll return in SpaceX Dragon and get it from SpaceX and get it back to the customer about a month later. There we go. So what happens to your hardware when you deliver it to Alpha Space? Well, we have a Class 10K clean room where we do all of the experiment integration into our carriers. We do a thermal bakeout for some, especially the material samples, if they want a really pristine surface when you're launching into the MISSE environment. We'll install everything into the carrier. We'll do environmental testing of the carrier. That's usually a thermal test as well as a vibration test to make sure everything gets certified for flight. And then we'll launch on the vehicle of opportunity, usually a Northrop Grumman or SpaceX launch. Once we get the carriers on orbit, it's important to note that the carriers actually get launched in the pressurized volume of the cargo resupply missions. The crew takes the carriers out, they unpack them, and they'll install them on what we call the MISSE transfer tray. So the transfer tray is really a holder, and it's to hold several MISSE carriers so that then when it goes outside of the GEM airlock, the ISS robotics will then capture the MISSE transfer tray with all of the carriers on them and take all of those carriers out to the MISSE flight facility, which is near the solar array on ISS. Once we get there, or the robotics get there, they swap the carriers that had been exposed for 6 to 12 months with the new carriers. And the carriers that had been exposed get placed on the transfer tray and then brought back into the airlock for the crew to pack up and return to Earth. And for the on-orbit MISSE carriers, then everything gets operated on the MISSE platform through our ops center in Houston. Let me talk a little bit about the carrier, which is where your technology payload experiment is mounted. So it accommodates a wide variety of experiments, anything from electronics, sensors, you can have cameras, you can have antennas, optics, you can have something as simple as a material or a coating or a treatment. We've even flown some biological experiments on the external platform. They can be passive, meaning they don't need any kind of utility, but they can also be powered, active, and require commanding and data as well. So we have all of the utilities necessary to fly virtually any type of technology. We do have a solar cell testbed that's installed on the zenith phase of the MISSE facility. And when connected to the solar cell testbed, your solar cells will get current versus voltage curves. And you can have several solar cells integrated at the same time, each getting a different IV curve. And if you're thinking, you're looking at the dimensions and say, well, my experiment as it is now won't fit. Well, we can certainly customize, and custom carriers are also highly possible and have been done before for us as well. So our basic services are, of course, the structural mounting. So if you have just simple material or something that you want exposed, well, it can be square, rectangular, round. It doesn't matter, but the standard is a square or round. We have volume available that's underneath the deck, and you can see that kind of on the picture of the carrier there. The exposure decks, what I'm talking about, are kind of the aluminum panels that are on the top of the carrier. There are 2 of them per carrier, but the underdeck volume is underneath that exposure deck, and that's where a lot of electronics and other things like to fly. So, but from a basic standpoint, standard basic mounting, the volume underneath the exposure deck. We have a temperature sensor on the deck that you get temperature data for the carrier. And we also take a high definition photograph of the exposure decks once every month for downlink and distribution to customers. And we'll also provide contamination data monthly, excuse me. There's also power, data, and other types of sensors available. DC power from 28, 12, 5, or 3 volts are available. There's RS-422 or Ethernet connections for technologies that require communication and commanding. Typically, the data rate is anywhere between 3 and 5 megabits per second, but higher rates are possible at times. It is a shared bus that we're on. So the UV intensity sensors are available, as well as the total ionizing radiation dose. And we can provide you with atomic oxygen, information through a witness sample. And of course, we have the solar cell test bed connections for the IV curves. So we've flown over 780 experiments so far since 2018 on the commercial MISSE facility. Some examples. We've flown, and I think it's still on orbit, the electrodynamic dust shield. We have a contamination monitoring package that we're flying for the ISS program manager. We have high efficiency solar cells that are flying. We have an RF antenna that is going to fly. And then just simple stuff, you know, some kind of laminate, some kind of composite, a lot of 3D printed materials and structures. Really, we can fly virtually any type of technology on the MISSE platform. Customer base is very diverse. So NASA, government agencies, universities, big aerospace companies, small companies. We even had a few high schools fly sponsored experiments on the MISSE platform. So we work with virtually everyone. So please don't feel that you won't be able to fly something on MISSE, because we've worked with virtually everyone. So why would you test with MISSE? I mean, it's a very flexible, very unique facility, we think. So it creates an opportunity by having a consistent launch and return cadence. So every 6 months, we're going up and bringing things down. We've lowered the barrier to entry for a lot of new products and materials, especially things that are going to be, you know, for space application, but also for terrestrial application materials and other technologies that just want an extreme test of their capabilities. So you won't need to pay any launch costs. You won't need to pay our costs for the integration or flight on MISSE through this RFP. And then, you know, for the hardware return, it really gives you an opportunity to take a look at what may have failed, but what worked well. It may have worked better than you thought in the harsh environment. So we're very fast. We're always sending flight hardware up in a rapid cadence. Every 6 months, we make it really easy for everyone to fly. So we work with startups, small companies, academia. You know, just contact us. So I'll be your point of contact. If you'll have my contact information later in this presentation. But if you go to the Alpha Space website, we have email contact information there as well, and the info@alphaspace.com comes to my email address. So I'll be your point of contact moving forward and getting you quotes, and also just stepping you through the process for flying on this. So it really is easy. Just contact us and we'll get you going. I have a short video here that'll take you through what it would be like on MISSE. So there is solar arrays in the background, and the transfer tray is kind of on the left edge of the solar array. So the robotic system on ISS captures the MISSE carrier from the transfer tray. And you'll notice that the carriers are launched in a closed orientation. That's to protect any kind of technology or sample that might be on the deck during launch. And then the robotics then install the carrier onto what we call the MISSE flight facility, which is a structure that's attached to the truss that also has power and data connections on it. Here the robotics are making connections for structure and electrical commanding. And then once connected, then after a while, then we open the carriers, usually in darkness, to provide consistent lighting. So once the carriers are open, then the full exposure to the space environment begins. And you'll notice that on the lower right, another carrier will open. So there are 4 faces on the MISSE facility, the platform out there. So that gives you exposure to all 4 directions on the facility. And that's the trolley that takes the cameras through the decks to take the high definition photos of the exposed samples that are on the decks. And we then provide the photograph of your technology to you once per month. And that concludes my presentation. And we do have some contact information for you available. Let's see if I can control that. It's not. There we go. So yeah, that's my contact. I'm Mark Shimbera, Director of Business Development. There's my email address. Our website is alphaspace.com. Please, you'll find when you get to our website that we will have a link for you to get a quick reference guide. And that quick reference guide will provide you with a lot of information, as well as a questionnaire that should provide enough information for us to provide you a detailed quote. And if it's not enough information, then of course we'll contact you and we'll work with you and get the information we need. So with that, thank you. Thank you for your attention. Thank you for considering flying on MISSE and responding to this MISSE RFP. And with that, Ryan, I'll turn it back to you.
All right, great. Thank you very much, Mark. So we have a couple questions that have come in. If you have more questions, please continue to submit those. But we'll just kind of work through these questions one at a time. And as a reminder, this will be up on the website, this webinar, and also the question and answers will go on our Q&A for our website as well. All right. So the first question: will the funding for the IP go through the researcher or directly to AlphaSpace? So the answer to that is that'll go directly to AlphaSpace. That doesn't need to be routed through the researcher, so you won't have overhead in that case. So you don't need to worry about that. You will need to get a statement of work and budget from AlphaSpace, which you'll include as part of your proposal, but that would be the extent of that. Next question: will we be able to use other implementation partners for instrumentation development, or must we only use Alpha? So for this solicitation, we're only considering funding for AlphaSpace for these. If there was a need to develop your ground-based systems and you needed to use someone else and you are able to pay for that from your costs, you would be able to do so. But in terms of what you could request from the National Lab for this solicitation, it would only be for AlphaSpace. Let's see. All right, so Mark, this is one for you. Has MISSE flown high outgassing polymers or low vapor pressure metals? I'm interested in a study that could result in cross-contamination of adjunct experiments.
That's a great question, and I will have to defer that to our team because I'm not up on exactly what materials have flown. I think that would be a question that I would have to answer from our team. So please contact me offline and I'll get an answer to you on that.
Okay. All right, here's a couple of questions that kind of all came in. Can we include overhead for the proposed institution? So in that case, no. Right now, we are only providing funding for the implementation partner costs, those being of AlphaSpace. Since we are not providing any funding to the institutions, there wouldn't be overhead in that case, at least from the perspective of the budget. So the only costs that you're able to ask for right now are the implementation partner costs. And that kind of then goes and then answers the next part of this question. Can travel costs be included? For example, to visit AlphaSpace or see the launch. Again, right now we're not accepting requests for that funding. We're only doing the implementation partner costs. All right. The next part, and Mark, this will involve you. Can we include costs for AlphaSpace to run control samples under ideal conditions? For example, thermal vacuum bakeout, environmental testing, which may change the materials. So have you guys done that sort of thing before?
Yes, we do. We do have a thermal vac chamber at AlphaSpace, and if that isn't appropriate for the type of test that the customer wants to do, then we can certainly contract out other test facilities. So we can do ground controls and do some testing for controls. Yes.
Okay. From the national lab side of that, can you request or include costs for that? Yes, if the costs are coming from AlphaSpace, they, please talk with them during your conversations so that they can include that in their statement of work and budget, and then those would be allowable under the solicitation. Okay. Mark, here's another technical one. Do your environmental sensors measure electron flux or incident photon flux?
No, the sensors that we have currently are atomic oxygen, UV intensity, total ionizing radiation, contamination, and temperature. If there is a unique sensor that you would like to fly on the MISSE platform, then we can certainly include that potentially. We would just need to know what type of sensor you want to fly.
Okay. Do you have any on-orbit characterization capabilities, for example, a spectrometer?
No, we don't currently have that. But again, if the customer wants to fly that, it's certainly something that we could potentially do.
Okay. And then I assume that the Kapton H sample measures atomic oxygen exposure via measurement of mass loss?
That's correct.
Okay. All right, let me see. So Mark, for my own benefit, you had mentioned the timeline for MISSE 15. Do you know when the timelines for MISSE 16 and 17 might be?
No, I don't. We have target flights for those that were not yet manifested. So
okay.
Really for MISSE 15, it's spring. MISSE 16 will be in the fall, usually August, September, maybe October. So if you look spring, fall, if you'll think of March and September as the two flight launch dates, and then back up 5 months from there, that's when we would need your hardware.
Okay, great. Mike, I assume that you're feeling left out, so I'll throw you a question as well. Is there any public information on the types of experiments and results?
So those, there is no requirement to post public results. It's up to the principal investigator. Certainly information that is gathered by AlphaSpace regarding the types of materials that they are at liberty to share that information with new principal investigators so that they can benefit from the experience and expertise of AlphaSpace and their ability to expose those materials and what's been learned. NASA does maintain a physical sciences database that will be a repository for any information that can be made publicly available. And there is certainly some information that's already deposited there on the use of the MISSE platforms. Mark, I don't know if you wanted to add anything to that.
Other than what you just referenced, there is a MISSE material database that has some, at least from what I understand, it has a lot of the information from material exposures from the MISSE 1 through 8 flights, which were the NASA flights.
Okay. All right, so I think right now we have one more question, please. If you have any other questions, submit those now. But the last question we have so far is, can we develop an experimental plan and small hypersonic structure that can do a free fall from space back to Earth. So I don't believe that that is compatible with the MISSE flight facility. Mark, please correct me if I'm wrong. But that would likely not be under this solicitation. There are various satellite launchers on the ISS. So if you are interested in something like that, you can reach out to us at info@issnationallab.org. We are continuously taking unsolicited proposals as well, Mark. But that isn't something that you have currently, right?
And that's not a current capability. That with additional hardware development, we could certainly attempt to do that, but we don't have that capability currently.
Okay. Okay. So we'll just kind of hold on for a moment, and just in case there's any last-second questions that come in. While we're doing that, I will remind you all that if you have any other questions, that you can submit those to info@issnationallab.org. We are here, and let me see if I can pull up. Oops. Well, now I'm just, here we go. And here's Alpha Space's information. Please reach out and contact them. You will need to do so in order to submit your full proposal. So please do that as early as possible. Okay, so one last question here. Is there a timeline required? For example, when the experiment samples must be received by Alpha Space and on orbit. So, Mark, do you want to try to take that one?
Yes, and generally we need your hardware sample technology in our hands about 5 months prior to launch. So for the MISSE 15 launch that's scheduled, I believe, for early April of next year, that means that we would need your hardware sample to us by around the November timeframe of this year.
Okay, great. Another question here. I do not find where the submitted budget info is evaluated. What are the evaluation factors for the budget and the statement of work for researchers and Alpha Space? Mike, would you like to take this?
Yeah, certainly, Ryan. So the submitted budget, again, is going to be focused on covering the cost of the implementation services provided by Alpha Space. If you do have additional budget requirements, you can include those, but again, we are not providing funding for the institutional costs or principal investigator costs associated with that. So those types of budget request above what is required in the statement of work provided by Alpha Space will be used to evaluate the proposals as they come in.
Okay, great, thank you. So with that, I think that's all of the questions that we have out there. Remember, the questions that you submit to us, oh, I'm sorry, maybe we have one more, but as I was finishing there, the question that you submit to us will be posted online. So, you know, keep that in consideration if you have proprietary information that you're trying to get at. All of that information is online since this is a public solicitation. Okay, and I think that the last question was a comment, but so I think that's all that we have for today. Thank you so much, Mark and Alpha Space for your help with this webinar, and we are very excited to see the kinds of experiments and proposals that everyone has and puts forward.
Absolutely, we're excited to help. So please submit your quick reference guide questionnaires, contact me, and we'll get the process going for you. Thank you.
All right. Well, thank you all, and everyone.